All right, so good morning. Today we're going to talk about how ML supports the 60 million daily active users using Roblox by supporting the 200 plus people who use the platform internally. And we're about a 2,000 person company, so supporting 10% of it to 15% of a primarily engineering and infrastructure company running data science is basically, we're kind of a big deal. So just a little bit about myself. I'm Omri Shiv. I've been in the analytics and ML space for the last 10 years, doing anything from consulting to engineering, analytics engineering, ML, deep learning, and then ML ops. I started at Roblox just over 3 years ago as one of the founding members of the ML team. And today I spend most of my time on the Kubernetes and Kubeflow environment, bringing some more functionality to the environment and making sure that it stays up and adding features and making people's lives easier. And it's my absolute pleasure and honor to be speaking to everyone today. So really, thank you very much for having us and letting us share what we do. So first off, if you don't know, this is Roblox, or at least a very small part of it. We allow you to build experiences. There's millions of them, and you can go and play and communicate with friends and do all that kind of stuff. And if you see that handsome guy on the right, that's my avatar. So if you see me in there, or if you see him, that might be me. ML is absolutely everywhere at Roblox. When you launch the app, you get experience recommendations, you get friend recommendations. We use ML for moderation. It's kind of hard to escape the scale of what we do with ML. Last year, my colleague presented here, and we were really excited about this video to animation project and how cool it was that you can upload a video and then animate your avatar. So that was last year. I still think it's pretty cool that you can just drop a video and animate your avatar with it. But again, that was last year. What are we doing this year? So LLMs and generative AI are exploding in Roblox just like they are everywhere. We're seeing a dramatic increase of use cases that we need to support. Anything from being able to type what it is you want to program, like changing a color or making objects, to being able to create an avatar for yourself just by expressing what it is you want them to look like. I could spend all day talking about what I do, but I only have 30 minutes and I've already used a bit of it. So I'm going to kind of split the talk into 3 categories: users, infrastructure, cost. And it's kind of where I think we've had a lot of impact as a team, and definitely some challenges that I kind of want to highlight throughout the talk. So we'll start with users because if you don't have any users, you don't really have a reason to be doing what it is you're doing. So for users, we internally use Okta as OIDC. And we didn't want to have to basically open a ticket to our IT department who manages Okta to say, all right, this user is allowed to use the environment, please add them. For 200 people and every new hire, that's just a nightmare. So we had them just allow everyone. We disabled the registration controller, so if you open the page, you don't automatically get a profile. But this created a different problem for us because now every time anyone wanted to join the environment, we had this awful screen of having a ticket from them that said, please create an account for us. And then we would obviously ignore it, just like we do with most tickets. But things got lost, and so that wasn't great. And we just hated this flow. So we created a CLI tool where you can be prompted for what it is you want. So I want to create a user, I want to create a service count, I want to add a permission to a user, and it would prompt you for their LDAP information and where it is you want to make them. And so that kind of worked, but we didn't have any ability to persist this information. It would just apply it and then we'd say, all right, go check your account. And then, if we had to do like a migration, a new cluster, we would then have to go and dump, everything from this environment, copy it over, and reapply it. And so we didn't like that one bit. And so we decided to write a controller, which you'll hear me say a lot because we like automating things. So what we did, wrote a controller, custom resources. The profile one on the left should be pretty similar to what you expect to see a Kubeflow profile. We had a little bit of metadata that we're able to use for alerting and stuff like that. On the top right, we have a service account. So with this basically 3 lines, we're able to define we want a new service account in which namespace and what role, and it will go and create all the permissions for that service account. And likewise with the permissions, you tell it where you want to create the permission and what namespace, if it's a user or a service account, and what role and what their name is. So this was really great. We were able to kind of persist this information and allow us to have some sort of auditing for it. But we were still stuck with this screen of this awfulness because we still had to do this. So we took it a step further and we created an Argo CD-based repo where our users are now creating their own profiles. And so we have users who will go and add themselves to different namespaces. They write these specs themselves. They don't need us to do it. We get notified that, hey, all the linters have passed. The users are ready. Their manager has approved it. And then we just hit merge, and that's it. They have a user account. We're able to see whether the environments are synced. Unfortunately, I grabbed one where our dev one is out of sync, which usually happens since we don't want to auto-prune things. So we sometimes get out of sync there. But we've had over 250 different PRs, and pretty much all of them were written by users. So it's been absolutely a game changer for us as far as productivity improvement. So the next question is, you created users, but how do you give them access to Artifactory, GitHub, all of the alerting that they might need in their namespace? So what we did, just like before, we wrote a controller. We started with this, and this was the controller we initially wrote before we wrote any other controller. So it was really bad. All the YAML was in text and code. It was, if you needed to update something, you basically updated the controller, then you had to kill it, and it would go and replace all the resources all at once in all the namespaces. It was really bad. We heard about Kyverno through our friends at Aricto, who wrote a blog post about using it for security, and we found out that it can actually deploy manifests. So we have a bunch of cluster policies that now on a namespace creation will sync pod defaults, will sync secrets, will sync alerts, and it just goes and does all of that for us. So it's been really great. Having an environment that supports users is only good if they actually want to use it. So we had to do a lot of usability improvements. So it's a little hard to see, I apologize. My colleague spoke last year about the SDK we've written, so I don't want to go too much into it, but basically we're able to programmatically create pipelines by some DSL. We took it a step further over the last year. If you're working in a notebook server and you run a pipeline from that notebook server, we actually snapshot the environment and are able to reuse that for your pipeline steps. We also immediately, in that same notebook, make all of the outputs and intermediary steps available within the notebook. And I'll go a little bit into that in a little bit. And then you can use custom Docker containers for those images as you're going through the steps. And it's great that we support that, but that really only works if people want to write Docker containers or Docker images. So again, what we did was We heard from Roche about the build pack. We went a little different route where you have a repo, like a mono repo, with all the Docker images, the definitions, and we will automatically build them for you. So you put your Docker file in there, and you can see I created a Triton container with our SDK, and I got a little comment under it saying, here's where it is. So we have people who would have never written these things before writing them. I saw last night a technical director put up a Docker image, which I would have never expected them to do. So it was great to see that these things are coming around now. One of the complaints we've heard a lot of is people don't like Jupyter, especially software engineers. They like VS Code a little more. The problem is, if you're working locally on a computer, how do you get your files into the pod remotely? So we told them at first, like, hey, start a Git repo, check your code in, and then pull it on the remote server. People didn't really like that as an answer. It doesn't seem very productive. So what we did was we deployed telepresence, which lets you mount a pod file system locally. And so, of course, now they need user accounts and all of that. Well, we said, hey, look, we've already got this controller for configuring all your profiles. Why don't we create a new custom resource that allows you to get a remote account? So with this 5 lines and a merge into our same repo, you now have a remote account where you can work remotely. And I've gotten some feedback that people have said, like, oh, I can finally do my job now. So I don't know what you were doing until this point, but it's been great that people feel productive by this. So we run an environment that trains models anywhere from really small toy ones to CLIP and LLMs, and this has been the most difficult sort of engineering challenge, I think, for us, is how do you work with storage in Kubernetes? And so people want the fastest possible storage that's the most available, the biggest storage, and granted, they may not care about cost, but we do. How do you achieve this? So we looked at the landscape. We're in AWS, so what's available to us? S3 is infinite, but it's not a file system. EFS is kind of infinite, but it is a file system, but it's not so performant. We looked at all of these, and there is not one that kind of fit everything we needed. So we took a tiered approach to storage. So I mentioned, we have this ability of getting the pipeline into the notebook. So what we do actually is, when a namespace is created, we automatically mount EFS, and they get a data that's available to all the notebooks in their namespace, and a runs, which is for the pipelines, and then each notebook server gets its own home directory. And so it's been kind of amazing. One, we tell people, they say, oh, I made a notebook, but it doesn't have enough RAM, or now I need a GPU. And we tell them, all right, just delete it and create the one you want with the same name. And they say, isn't my work going to be gone? We say, no, just start it up again. And it took a little bit of work to get them to realize that, oh yeah, it comes up, and it comes up fast, and all my work is still there. And it's always kind of a fun thing to see that people didn't expect that, and so that's been really cool. You might also, if you're familiar with EFS, you think, well, how are you able to create dynamic volumes for 200 people? The dynamic provisioner doesn't allow you to do that. And so we wrote a controller, and we actually used static provisioning, but we made it dynamic by basically creating all the underlying resource while it waits for the volume to be made available. You might also notice this EFS ID, which is a templated variable. So we run a few different volumes for each cluster. So we have a general one that's kind of available to everyone, and then we have ones that are team specific because they need more throughput or higher performance. So our controller will retemplate this once it gets to it, and it looks at the profile, which has a EFS ID, and if it's there, it'll use that ID. If not, it'll use our global one. And one thing I will say, this works for the majority of people. Data scientists who are just doing experimentation in Jupyter, they don't mind the performance. Even people who are doing, ML training in pipelines, it mostly works okay. We have some teams who still say, no, we need NVMEs. This is not fast enough for us. So we do support NVMEs. As I said, we have like a tiered strategy. I would not recommend supporting NVMEs. It kind of forces you to one node. It's kind of a burden to support in a long term. So if you can avoid that, that was definitely a lesson for us. Is don't use NVMEs if possible. Scheduling. If there's anyone from AWS here, we love you, but we would like to pay you less money. So we've spent a lot of time on scheduling recently. Kubernetes is great if you have highly available stateless workloads, which is kind of the complete opposite of what machine learning is. We have Kubernetes, especially in an elastic environment, is going to allocate pods to the least utilized nodes. It gets expensive. So just to kind of illustrate. So we have 4 nodes here, which are at capacity, and then 4 pods which need to schedule. So they will bring up 4 nodes, and these pods needed some resource which scaled up a node that was slightly bigger than what they needed. So bring up 4 nodes because we're trying to minimize the cost of the node themselves. You get a node that's cheap, or as big as you need. 4 more pods come in. They need scheduling, and because we are now round robining to the least allocated nodes, they'll go on 4 more nodes. Ideally, what we want is this, where we can pack them onto 2 nodes and then get rid of the other 2. This is not kind of what you get out of the box. Same thing with GPUs, except it's more expensive with GPUs. So here we have 2 instances with 4 GPUs allocated, so 4 available on each one. We have 2 workloads with 2 GPUs being requested. They're going to go on to 2 separate nodes. And then now we have a 4 workload pod, or a 4 node pod, or 4 GPU pod that's trying to schedule, and it can't. Ideally, what we would have wanted is them to pack together, and now this one can get scheduled. So we had this problem where besides the resource misconfiguration, we caused this GPU fragmentation. Additionally, we have GPUs are really scarce resources, right? Especially if you're trying to get them from cloud, where you're competing with every other company for all of these resources. So what we do is we basically hold on to them just like every other company does, whether or not they're being utilized. And so we have teams who say, all right, well, we need 4 P4s, and we want them when we want them. And so we say, okay, you guys are budgeted for 4. But we can't really restrict what's on them. So they would have to come to us and say, hey, someone's on our node, kick them off so that we can do our work because we paid for them. it was getting really tiring for us to kind of have to manually manage this. So I'd love to say we wrote a controller for this. No, instead we wrote a scheduler. So how do we optimize all of solving the problem of resource fragmentation, the elasticity problem, and making sure that people land on the node that they own? So we tag the nodes with a new label, instance owner, and the namespace. And so we wrote a scheduling plugin that will basically, it extends the preemption plugin for Kubernetes, and it looks for pods that are on this node that maybe don't belong on it. So if a pod comes in that says, hey, I need to go on this node, I own it, it will look for user pods that are on it that don't own it and kick it off. Saves us a lot of time. We don't get paged at 10:30 at night, 2 in the morning, when someone decides they want to work instead of sleep, and ask us to migrate workloads for them. We also reconfigured the node resources fit, which is a feature of the scheduler. So instead of using the least allocated, now it uses the most allocated. And then we use Kyverno for mutating all the incoming workloads to add a preference for a user's owned nodes if it exists. Speaking of scheduling and elasticity, I don't know if anyone's experienced this. So we love EKS for the most part, works great, except for this one default feature. We had this issue where because of the scale that we get workloads in, so we sometimes scale up 200 nodes all at once for inference. And we have managed node pools that span multiple availability zones. So all of a sudden, we bring up 200 nodes, 150 of which might be in A, 49 of which might be in B, and 1 of which might be in C. It works great to scale up and bring up the nodes. What doesn't work great is because of EKS's default sort of high availability, where they want to make sure that you're spread across AZs, they will also bring up a bunch of other nodes and kill all your workloads to spread those workloads out. So for a couple days, we were getting a bunch of people furiously complaining, hey, we have these training jobs that are getting killed, we don't have logs, it just says pod deleted, and we had no idea what was going on. So the cluster autoscaler wasn't telling us that it was scaling down nodes, they just disappeared. And it took us a little more time than I'd like to admit to figure this out. So if anyone is thinking about doing any of these things, I would highly recommend disabling this feature, which is easy to disable, you just need to know to do it. We really like this octopus. It's, if it wasn't clear from our user repository, we also use this for our deployments. So we have a deployment repo that has all the kubeflow manifests, and we use Volt for configuration. So we have very clean manifests, and then each environment has its own configuration, and so we're now able to manage a fleet of clusters from one central Git repo. It's really great. I know we might hear about another great tool a little later on today, and so I would highly recommend this over manually trying to manage your clusters. One thing I will say is we had another learning experience with Argo. If you're using autoprune, which you might, we specifically disable this on the user repo. We did not want to delete any user files unintentionally, but specifically on the environments repo where we are templating a lot of files on sync. If your templating fails for whatever reason, and you don't set a pipe fail on your templates, then it just thinks all of your manifests are empty and will delete your entire cluster. This happened to us once or twice, thankfully, over a 24-hour period. So we figured it out, we turned it off. Definitely something to keep in mind is, check to make sure you know what auto prune is doing, and thankfully just as quick as it deleted everything, we could reapply it, and the downtime was very short. As our for security reasons, our clusters are internal only. There's no access from the outside internet into them. You have to be on VPN. Works great with all our microservices because it's directly connected to our internal network. Doesn't work great when you're trying to have anyone here who wants to play Roblox and needs direct inferencing capabilities. So we wrote a proxy which is able to listen on our public load balancer, does all the sort of auth, so we don't have to code our auth tokens into the binary, which would be a problem. And it keeps us secure by allowing us to get into the ML infrastructure. And I guess just to give you a picture, this is kind of what it looks like from the networking side. We basically popped in this proxy right there to allow us to do that. Cost is something that's really important to us. If you're serving 60 million users a day, it's definitely not cheap. We're constantly training, experimenting, running inferences, and occasionally leaving things running when they shouldn't be, like this P8 I have running, or P3.8 that I'm running right now. So we're constantly trying to make people conscious of how much they're spending. We have a superset dashboard that's exposing all these metrics to everyone on a team level, on a namespace level, so they can see how much their workloads are costing, and also, just as importantly, how much they're actually utilizing the resources that they're requesting. So it's definitely brought a turnaround in culture where people are going to these dashboards saying, oh, I'm oversubscribed on my nodes, and they're actually actively tuning their jobs and their requests to bring these costs down. And last week, we also added resource quotas. We ran a job to aggregate over a couple months the total utilization by namespace and the average utilization, and implemented resource quotas on every namespace. And certainly people are now having to cut back on what they're doing because they can't start anything. So it's been really good. Finally, we have obviously we're running our Kubeflow environment in the cloud. We have a huge fleet of data centers as well that do not run Kubernetes. So we can't run our Kubeflow environment in there. So we came up, and we have a lot of excess compute because the trend of people playing through these data centers is kind of cyclical over a period. So we have this solution where, using our SDK, you can deploy your models internal to the cluster or to the data center by just telling it where you want it. And so we're able to now leverage all this excess compute and save us a bunch of money. So finally, what's on the horizon for us? GPU sharing. We want to increase the availability and optimize the utilization, further defragment, the GPU workloads, and add some observability that we won't have once we start splitting this up. We want some CI/CD for workloads. We talked about having it for the profiles and all the users. We have it for the environments. Now the next step is having it for the actual workloads. Model configuration as a service. We want to be able to take a model, do automated load testing, basically a hyperparameter search over the configuration to figure out, do we need to change some Knative parameters? Do we need to put it on a different node type? Figuring out, based on the throughput requirements, what's going to be the most cost-effective way. And then finally, Josh mentioned the importance of LLMs coming up. We're doing LLMs already, but further creating gateways and some performance tuning and explainability. So finally, why Kubeflow? So I started at Roblox 3 years ago. I spent 3 years before then building an MLOps platform from scratch. Kubernetes wasn't the de facto scheduler back then. There wasn't anything available, and no one knew you could run, deep learning and machine learning on Kubernetes. So it was a real big honor to start again 3 years later with all of these person hours from everyone in this room and the community having driven a platform that's open source and available. And so I think we're all here because either we're considering it or use it. And so I really want to thank everyone for providing us such a great platform for it. So thank you.